So I thought I would just make a video of this as I'm going through the key, or making the key, I guess. So first we have linear, right? Part A. This is on page 11 of your notes. If you're a group that maybe has an edited version of this, it might be different. But here we go. And so basically what I observed, right? I wish I would have mixed them up, but anyways, this equation here has a degree of 1, which is linear, so it could be like this or this. Then I focus on the leading coefficient, which is positive 3. It being positive tells me that it's going to go from quadrant 3 to quadrant 1. Remember that, the end behavior. I find the x-intercept, right? So I type this equation into my calculator. I've already done this one and went on to the next example. So I will do the third one and walk you through it. But I type this in and I make y2 equal to 0, creating a line right along the x-axis to find the intersection of those two lines we've created. And that gives me the x-intercept. The y-intercept is straight from the equation, right? So with a linear, that's really all the critical points, the important points you can. So I label x, y. I decided to go with a scale of 1, right? Every box is worth 1, as you can tell here. And I mark the x-intercept, the y-intercept. In this case, you can get the exact locations. You need to make sure you do that when it's possible. I label it with the equation. I put arrowheads on the line, especially if there's no context. That is the case. Okay, here is the next example. Don't know what happened there. And so here, degree of 1 again, linear, it could be this or this. The leading coefficient is negative, so it's pointing down. I proceed to find the x-intercept the same way. You might have to make some changes to your window, right? Because you can tell just by looking at this that your y-intercept is 46, right? So that means that if your window is set to 10 y max, you're gonna have to increase that to, like, let's say 50 to be able to fit all of that in. Oh, that is this one right here, right? I actually have it. So I had to increase my y max. Going to your window, the y max had been increased to 50 right away, and then I just went ahead and graphed it, and that actually worked out for me quite well. Okay, and so keep that in mind. There you go, it's a little brighter. And then I went second trace 5 to find that intersection, and that's 4.29 rounded, right? So I get that, I get the y-intercept. Having such a large y-intercept makes me have to change the scale, and I actually make every 5 boxes worth 15. That is consistent, and that allows me to put the 46 up there. And then I use a scale of 1, right? Every box is worth 1. I make every 5th one worth 5, right? And then I place those points, I connect it, I make sure the equation is included, and away you go. Okay, here's the next one here on page 12. Let me see here, focus that in. So here I'm going to proceed. First and foremost, I'm going to enter that equation into my calculator, and notice how large that y-intercept is, right? So I want you to be mindful of that. So before I even graph it, what do I know, right? The degree is 1, which means it's linear, which means it's a straight line going up or down. Okay, then I know, I look at the leading coefficient, and it is actually positive 19.31. That's also known as A, right? If I ever asked you for the value of A, that's the one. I know that the y-intercept is 103.8, right? And this, because it's positive, it tells me that the line, I'm expecting it to go this way. Okay, so we go ahead and graph it, and it actually works out quite well. I just have to increase my y max even more. I'm going to go to like 125 perhaps. That works quite well. I'm going to go ahead and find the x-intercept right away. Doesn't matter where you are, just hit enter, enter, enter. And there you have it, right? The x-intercept always include keystrokes, right? So y2 is equal to 0, and then second trace 5. And you can see that I'm almost making it look like a doctor's note, right? And that's fine, as long as you tell me what it is. So there's my x-intercept, my y-intercept. X-intercept is reasonable, small, y-intercept not so much. So how are we going to make this work? Well, as always, arrowheads on the axes is just to help you out, right? Make it a little faster, x, y. And so I will make everything worth 1. Every box is worth 1 along the x. I'm consistent there. And to fit in 103, maybe 25, 50, 75, 100, that's pushing it. So maybe I'll do this. I'll make every fifth box 50. So basically 10 units per box. And that'll work just fine, okay? And you gotta be consistent along that axis, right? And so here we have it. Let's place it. This is negative 5.38. This would be 6 right there, so it should be closer to the 5. There it is. And 103, it's right about there. It's very close to the 100, right? And then you grab your ruler and just connect them, and you're good to go, okay? You can probably skip this example because I'm feeling, but at this point you get how it's supposed to be done, okay? So let's go ahead and look at the other ones, quadratics. So here it is. And quadratic has more components to it. So it has a maximum or minimum, or what we call a turn, right? It will have a turn. And so we need to pay attention to that. That needs to be part of your graph, okay? So let's see here. Degree is 2. This is a quadratic. That means you should point out that, or I should point out that you should know already by looking at the degree what the general shape of the graph will be, okay? That should not be a mystery to you. And since the leading coefficient is actually a, which is -1, we would consider this to be pointing down, okay? Because of that negative, this is going to be pointing down. There we go. The y-intercept, how about we figure that out right away? In this case, it's 0, 9, okay? And then let's find out the x-intercept, or x-intercepts, perhaps. So now I'm going to proceed at actually entering this. I'm going to leave y2 equal to 0, why not? And so this is negative x squared plus 12x plus 9, just like that. And make sure the negative button is used, not minus. If you use minus, let's try to graph it, it's going to complain. Syntax is the way you typed it in. So if you go to go-to, it's going to point out what it doesn't like. That's quite often it works well to point out your mistake. And there you have it. I'm going to go ahead and graph it. Okay, it does exactly what I expected. It's pointing down. I need to increase my, you can go zoom and then standard, zoom 6. It actually didn't help me at all. So I'm going to just change my X max. I'm going to go out to 50. And I'm also going to change my Y max to, let's say, 100. Oh, that was a little overkill. Okay, so I can, if this is X max 50, I can bring it down half. And probably the same, just go up to 60 with the Y max, just to make it a little bit more centered, right? And so there we have it, second trace 5. I'm going to find this one first. So you go a bit closer to it, enter, enter, enter 3 times after calling intersect, right? So we're going to save what we're doing. Y2 is equal to 0, second trace 5, or intersect. And there it is, negative 0.71, 0. And the other one, second trace 5 for intersect, sorry. You go over the red one, I go up or down arrow to jump lines, right? And then I go closer to that one, enter, 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 and that one is 12.71. And that's 0. That's -1 times 10 to the -11 down here, if you're wondering what that is saying. We just, anything, as soon as it goes scientific notation, we just go 0, right, in this course. So there's your x-intercepts. So we have the y-intercept, we have the x-intercept. Now we need to turn, right? Turn points, turning points or turn. In this case, that is called the vertex. For a parabola, for a quadratic, that has a specific name. So in this case, it's the max, right? So we're going to go second trace max. So second trace max is the fourth option. I press 4. It asks me for a left boundary. Enter. I'm going to go for the right boundary. Enter, enter. And there it is. It's 645. Okay. 645 rounded. Perfect. So now you have the critical points you need to graph this and to come up with a scale and so forth. So let's go ahead and do that. So this would be X and Y. I'm looking at the x-intercept. So if I go up by 1, that'll work just fine. So meaning every box is worth 1. So 5, 10, sorry, 5, 10, 15. I use the same scale on the negatives, right? And then for the y, you need to look at all your y values. Obviously, these are zeros, but then you look at the y-intercept and the y value of the turning point of the vertex. So 45, you need to have enough space to fit that in. So if I go, I'm going to go 20, 40, 60. And same thing here. Just a couple there. You're telling me that the scale is consistent there. And now we're going to proceed at plotting our points. So -0.71, that's right about there, not quite at 1. And then 12.7 is close to 13, right? And the turning point is 645. So this is 40. And I guess that would mean that this is about 50 here, right? So I'm going to try to go 45 is about halfway between 40 and 50, right? So that is where I want it. And then you just make sure you don't go straight to that point. You kind of curve out and then through that, oh, the y-intercept. I forgot that, 0.9. So this would be 10 would be right about there. So this actually works out just fine, as it should. And then make sure it opens up and it keeps on opening up indefinitely, and then try to copy it to the other side. Okay. It should be more like a U shape than anything else. +9. Okay. So there you have it. That's your quadratic graph. Okay. Let's try another one. Here you have, just going to clear that, right? -4.9 x squared. I will, before I graph it, I will first look at what do we know, right? Before I even graph it on my calculator, I'm going to figure out what is it that I already know before. So I know that the degree is 2 because that's the highest power. That's a quadratic. And that means that this graph could be pointing up or down like this. I know the shape and I know the two options I have. The leading coefficient, which is A, is equal to -4.9. And that tells me that this parabola is also going to be pointing down. Okay, the y-intercept is right there. So I'm going to state it as a coordinate. Then you have the x-intercepts. Let's find these, the x-intercepts. And we're going to go y2 is equal to 0, second trace 5. It could be that there are none. Okay, that is a possibility. And this one definitely has 2 as well. I need to increase my y max. I'm going to go to 100. You could tell that the y-intercept is already at 54. This just keeps on opening or going up higher. So that works quite well. So let's go ahead and find, I already have y2 equal to 0, so second trace 5. And notice that my cursor is way down. Right? It says negative 100 something. You have options here. You can try jumping lines up and down. Right? Sometimes it goes right there. It's just that at this x value, you could be either on the blue line or the red. If you were to be on the blue, it's way down here, right? Or if you are on the blue, if you go sideways, you should see, for example, if I go left, it's coming up, right? So there you have it. I'm gonna hit enter, enter, enter. So that is 5.350. The x-intercepts seem to be fairly reasonable. I'm going to go over to the left, enter, 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 negative 2.060. So those are my two x-intercepts. So we've got intercepts there, and then I'm going to find the vertex. And in this case, it's a max again. So second trace max. Second trace max, that's 4. To the left of the vertex, pick a point, then pick a point to the right, enter, enter, and you get 1.64, 6723. Okay, so you've got that. All the important points are there. They will help you come up with a scale and so forth. So here we go. You can fast forward if you got this at this point. I'm going to go by ones as well here. 5, 10, 15, negative 5, negative 10, so forth. And for my y, I need to go all the way up to 67. So 20, 40, 60, 80, right? That works. Same thing going down like that. And let's plot our points. So the y-intercept, this will be 50 right here. So 54 is right about there. And then we have the x-intercepts at negative 2.06. It's so close to 2. It'll basically make a touch 2. And then 5.35 is also fairly close to 5. That's okay. And then the vertex is 1.64. So this would be anywhere in here, all the way to 67. This would be 70. So 67 is right about there. And this is a narrow curve, okay? A narrow curve based on, so we got to go through there and through there and make sure you open up, right? And so try to make sure it doesn't turn in. If it turns in, then we have to take away marks for shape, okay? And negative 4.9x squared plus 16.1x plus 54. So always make sure the equation is also part of it. And there you go. I will maybe do these without talking too much here. Some points up, positive, right? Intercept. Let's see if this one has x-intercepts. Oh, I made a mistake here. This is supposed to be 0.042, right? If you remember anything from grade 11, the smaller this number, the closer to 0 you get. the wider the curve becomes, right? And a large number greater than 1 turns into a very narrow curve. Plus x plus 7.49. And just as I expected, it's pointing up, right? So I'm going to change my y min to -50. That works pretty good. I've got both intercepts as well as the y-intercept. I'm going to go y min a little bit smaller. Sorry, y min. I'm going to go -30 maybe. There we go. I have everything I need right there. So the x-intercepts, let's go ahead and find them. Y2 is equal to 0, second trace 5. Okay, so second trace 5. Find that one first, maybe. That's -4.170. Then I'm going to find the one on the other side. I'm going to jump lines to the red, going up or down arrow. That's close enough. Enter, enter, enter. So that's -42. Oh, there we have some scale considerations for the x-axis, right? And notice how I get that weird scientific notation again. It's hard to see, but it's -2e times 10 to the -12. That's what that is saying. No problem, we'll deal with that. That's just 0. And then the vertex, in this case, it's a min, right? It's the lowest point on this graph. So second trace minimum. So we pick a point to the left of it. We keep scrolling right till you're to the right of the vertex, right? The vertex is right about there. Enter, enter. And then we get -23.45, -15.61. Very important for our scale, right? Let me just zoom out a bit. So here we are. Let's give this a try. So we have x and y. Make sure that will always be labeled. Down the road, that will actually have a unit attached to it and a name. Okay. And so in terms of my x values, I need to make sure I consider 42, right? So if I go 10, 20, 30, 40, that will work out. So every fifth box will work. And I have to make sure I do the same thing here. Okay. And then, so I've got to take care of the x. You might argue that you could have gone 20, 40, and so forth to make sure it fits in. I think we'll make it work. And then, and then we need to make sure for the y we fit in all the way to 7 and -15. So I think we can stick with a scale of 1 along the y. If possible, do it, right? It makes it easier to plot. So let's just start here. The y-intercept is, this would be a 6, 7, right? So 7.5 almost, close enough. -42.73 would be right about there. -4.7, this is 5, right? So 4.17, I should say, that's right about there. And we have our vertex, which is at -23, so this would be halfway between is 25, right? So 23 is right about there. Then we go all the way to -15, and then some, right? We pass it a little bit. So there's your graph. So it seems a little odd, but you can make it work, right? You just go like this, and like this, and then you curve in, curve past it, out, and then down. Okay. Arrowheads there. y is equal to negative 0.042x squared plus 1.97x plus 7.49. And there you have it. That's your graph for that particular equation. One more. Let's talk about what we know. Degree is 2. It's a quad. It's either up or down like this. And we know that the leading coefficient, in this case, A is equal to 4.25, which means this is pointing up. Okay. Y-intercept, we can read right off the equation. It's a big y-intercept, and which means you're going to have to already consider your window, right? You know where it's going. Let's figure out if there are any x-intercepts, and so this is when you graph it. Clear that, and I'm going to go 4.25 squared. See the numbers as they get bigger, it will make it more challenging to find it on your window, okay? In fact, you don't see anything. So that's when the y-intercept comes in handy. So I'm going to go window, and I'm going to make sure that my y max, right, this is pointing up, right? So it's pointing up, and this is your y-intercept. So it's probably a good idea to go maybe 5,000, right? Because it's going to go through there and then up. So let's graph it, and there it is, right? There it is, my y-intercept. So I just need to now change my x max. I'm going to change it to 100, and there it is. It works. No x-intercepts, right? None. Okay, so you don't worry about it. Then vertex. Second trace. In this case, it's a min. Okay, so second trace minimum. I'm going to go to the left of it. I'm going to go to the right of it. Enter, enter, enter. Oh, let's try it again. As soon as you deviate, you have to redo it. Oh, sorry. Second trace min to the left, to the right, and there it is. 2156. And that's 440.55. 440.55. Okay. It's hard to see when it's blue, right? Let me see if I can change that. I've changed that to a different color. Let's go orange. Let's try that. It's going to be easier to see. Enter. Still not easy to see, right? I think red would be best. I'll change that later. So here we go. X, Y, and here you have your scale. My y-intercept is way up there. Same with my vertex, right? But this is really the one. So I'm going to go 1,000, 2,000, 3,000. Okay. And I'm just going to go negative 1,000 here once on the, and for the X, really, I'm going to go vertex is 21, right? So we're going to go 5. Vertex is kind of like halfway, right? Halfway, it's the middle point, and it goes this way and this way. So you kind of want to go past just the 21. So it's let's go 10, 20, 30, and then we're going to go negative 10, negative 20. The same thing would happen if I asked you to do a scatter plot, which is when I just give you a bunch of points. You still do the same reasoning based on the points. You put your scale, you determine what your scale should be according to that. So this goes, if this is 2,000, then 2,500 is right in between. So we're going to go just below it. And then 21.5 that would be, this is 25, 22.5, so 21 is right about there. And we're going to go to 440. So 500 would be there. So 440 is right about there. And here's where you just try to come up with this and try to make it symmetrical. Okay. Y is equal to 4.25x squared minus 183.25x plus 2415.88. So let's see if I typed it in right. 2415.88. Yeah, we're good. So this is your graph. If you wanted to have a point on the other side, okay, if you wanted a point here to help you out, you can go y2 is equal to, what's the height here? What's the y value, which is exactly the same as the y value over here? And that is 2415, right? So 2415.88. And then you go second, trace 5, and you find the x value that way. So I'll show you how that's done. Right? You graph it like that. It's going to draw a line through there. And then we're going to find the intersect on this side. We already know that this is the y-intercept, right? And so that is 43.12 2415.88, which is what you expected, right? And so then you sort of know, like if this is 10, 20, 30, this is 40 here. So technically this should have been out here. So now that I'm talking about it, I will make that change, right? So okay, so you go out and over like that. And so that point was found this way, okay? And it looks a little bit more symmetrical now. Okay, let's keep going. Cubic, let's try some cubic functions here. So we know that the degree is 3, it's a cubic, so it could either go like this in general, right? Or it could go like this. It's got that squiggly motion there, right? And of course that can be more accentuated, but in general that's what you're expecting. The leading coefficient A is 1. So since it's positive, we're going to expect the same as a linear. The end behavior will be like a linear, like this. That's what we're expecting. Okay. The y-intercept, same as before, it's 0, 24. Let's look at any x-intercepts and any turns. This will definitely have turns. Okay. It will definitely, each maximum, minimum, these are the turns that it's asking for, right? So we're going to have to figure those out. Right? There could be 0 or 2. And so let's go ahead and do the same as before. Second trace 5. So I'm going to type this in first of all. So x to the power of 3. And then make sure you go arrow down, right? Or sideways arrows for it to come down. Minus 3x squared minus 10x plus 24. I'm going to make y2 equal to 0 already and hit graph. And there it is. I did expect it to go from here and then go up, right? So I'm going to go zoom 6. I'm going to reset my window. And lo and behold, there it is. It's actually much better on a standard window. All I have to do is make sure I see this maximum here, that turn, right? So I'm going to go increase my y max. I did know that, right? The y-intercept is 24, so for sure the y max should be at least 30, I would say. And there it is, right? So I've got the intercepts, I've got the y-intercept, I'm seeing the max and the min. Local max, local min. That's what we call them, because really this function doesn't have a true max or a true min, because it ends up going indefinitely in each direction. So we call them local. Okay. So second, trace 5 intercepts first. So I'm going to jump, and I'm just going to go along that red line. Enter, 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 and that's negative 3, 0. Right. And then second trace 5. I'm going to jump lines again and go right to the next one. Enter, 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 and that is 2, 0. And I'm going to find my third one, second trace 5. Go to that one, enter, enter, enter. That's 4, 0. I know it's hard to see, so apologize for that. Maybe I'll make this my red. I'll try yellow. Well, that's going to be worse probably. Second trace 5, enter, enter, enter. Oh, it's finding the red. Enter, enter, enter. Oh yeah, it's better on the screen, I think. Yeah. So here we go. And then, so the x-intercepts are done, and then turns, right? Local, max, min. And here you have multiple, right? So we're going to find the max. We're going to go second trace max. Let's do that first. Second trace max. So you have to kind of scroll to the left of it, enter. Go to the right, enter, and then enter again. There. And so it's negative 1.08, 30.04. And then the min, second trace min, 3, right, for min. It's actually telling you up here what you're finding, right? So there's no way to miss it. Left boundary, right boundary, enter. So that is 3.08, and it's negative 6.04. Okay, so here we go. We're ready to start our graph. So this would be an X here, and this would be a Y. Okay, and so you have everything you need. So it's safe to say that along the X, if I go up by 1, I'm fine. Okay, so 5, 10, 15, every box is worth 1. And then along the Y, I need to make sure I include the y-intercept. So let's see here, 5, 10, 15, 20, it wouldn't quite work. Okay, so I'm just going to go 10, 20. I'm going to use the same scale as the x-axis. Okay. So there you have it, your scale is set. And let's plot it. So how about, the y-intercept, this would be 25, so 24 is just right there. Then you have negative 3, 0, then you have 2, 0, and 4, 0. Right, those are my x-intercepts. And then the local, like the max here is negative 1, 30, right? So that's just past 30, is right about there. And the local min is at 3, negative 6. So this would be 5, so 6 is right about there. So now you have to be very careful, right? You kind of have to maybe let this guide you as to what needs to be done. But I'm going to go through here up to my y-intercept. Sorry. Oops. That's what I get for making videos, right? Let's try this again. I have to go to the max there. Over, and then it goes cross, It's going to go through the x-intercept to the min, and then there, and then it can go up like that. And this will go down like that, right? It's a bit of an eyesore, so I'm going to redo this part, right? So I want to make sure that it's supposed to give you indication that this will like keep opening up indefinitely, but there you have it. Okay, so that's your graph. Why? And this could be f of x, it could be anything. Most of these examples, if not all, are just y equals, but there you have it. That's your cubic graph. Okay, one more, and 3 is 3 cubic. A is negative 0.02, so this is going to be pointing down like this. Okay, so I'm shortening it shortening that whole process. So y-intercept is 0, 18.24, and then x-intercepts and possible turns. This will for sure have one x-intercept. Okay, so I'm just going to go ahead and negative 0.0 x to the power of 3, make sure you come back down, minus 0.3x squared plus 1.35x plus 18.24. If I make a mistake, I apologize, but I thought you'd rather. Oh, what happened there, right? So you can tell I'm expecting this, right? So I'm expecting there a tail. This part here is just not visible. So we're gonna go window x, the x min. I'm gonna go negative 50. Let's try that. And there it is. That's actually a little bit too much. So I'm gonna go negative 25. Let's see if that works. I just wanted a bit more centered. There it is. Okay. So I have everything I need on there. So let's go ahead and find the intercepts. I'm going to start with the leftmost here, enter, enter, enter. So I'm going to speed this up a little bit. At this point, you should be pretty good at finding them. Jumping, going straight across. It's close enough. Enter, enter, enter. 7.94. Okay, got my intercepts. Now I'm going to do the turns. I didn't tell, so I'm going to go y2 is equal to 0, second, trace 5 turns, right? Second, trace min. I'm going to do that one first. Oh, I'm all the way over there, so I'm going to jump, go here. But then I'm going to jump to the yellow, right, to my curve. So left bound, enter, right bound, enter, boundary that is. So that's negative 11.89, negative 6.60. Okay, and then second trace max. I'm just going to stay on the yellow this time. So left boundary and right boundary. So that's 1.89, 19.58. So I've got everything I need. So I'm going to go ahead and, so this is the x, the y. And keep in mind these numbers, the bigger they get, the more challenging this becomes, right? So now we're kind of just making sure you understand how to find everything. But then later on, you might have to adjust your window quite a bit. But just remember, you know the y-intercept, you know the general shape, all of that, right? So here we go. If I go by ones, I should be fine. Okay, and then my y values, I need to go all the way up to 20 and -6, and that is including. So if I go 5, 10, 15, 20, that works. This is -20 down here. Okay, so let's plot it. The y-intercept is 18.24 right there. And then I have the x-intercepts are -15.5, right about there, -7.37, and then 7 almost 8. And then I have the turns, the two turns, -11.89, -6.66 there. And then 1.89, which is almost 2, 19, almost 20, right? So now with the help of your graph, perhaps you kind of help, right? You're going to come like this through, and then through your x-intercept, through your y-intercept there, and then back down. So I'm going to go, at first, I will go light, okay, like that. Always like you want to create a curve, a smooth transition, right? So it comes down like this, it curves again, and then there you have it, right? So that's your graph. And make sure you don't forget your equation. X plus 18.24. That is all I have time for to do on this video, guys. So the rest I'm going to probably scan and post, but I can probably foreshadow a little bit. Yeah, they look like they're going to be about the same. This one is going to be really wide, right? So expect to have to expand your X max or min quite a bit for it to work. But that's all I have. Hope this helped.